Namaste children, welcome back again to this virtual class. So from the past episodes we are learning the chapter electricity, right? In the past episode we have seen about resistance. What is resistance and what are the various factors on which the resistance of a conductor depends. We have seen that resistance of a conductor is directly proportional to the length of the conductor, which means if the length of the conductor is increased, then the resistance will increase. So we can say that R is directly proportional to length of the conductor. We have also seen the resistance of a conductor is inversely proportional to the area of cross section. So R is inversely proportional to 1 by A. Here it shows that inverse relation. So by combining these two, we got R is directly proportional to L by A. On replacing the proportionality constant, we got R is equal to rho L by A. Here rho is the resistivity. On rearranging this equation, we will get rho is equal to RA by L. By substituting the value of RLA, we will get the value of resistivity. And here the resistivity is the characteristic property of any conductor. If the value of resistivity is more, then we can understand that it offers more resistance in a circuit. If the value of resistivity is less, then we can understand that the resistance offered by the conductor is less. So on the basis of this, we have seen some of the important numerical problems which are very often asked in the CBSE examinations. Hope you all understood that. In the next section, we have seen about the resistance of the system of resistors. We have seen that the resistors are those components in the electric circuit which offers resistance, right? In an electric circuit, we may have two or more than two resistors. How these resistors are combined in an electric circuit? There are two ways by which the resistors could be combined. The first one is the resistors in series. As you can look at the screen, here are the arrangement of resistors in series. Here in series, what happens? The resistors are arranged one after another linearly. Such an arrangement we call it as the series combination. In series combination, we have seen that the current remains constant, whereas the potential difference across each resistor changes, right? In today's video, we will be seeing why the current remains constant and potential difference changes across each resistor. And in the parallel combination, you see the resistors are arranged parallel to one another. One below another, the resistors are arranged. This is what we have seen in the last episode, right? In the parallel arrangement, it was found that the potential difference remains constant across the resistors, whereas current changes across each resistor. Now here exactly the opposite, the way we have seen in serial combination. Reason for this we will see in the later section. So this is what we have seen in the last episode, and also some of the important numerical problems also we have solved, right? So hope you understood all those numerical problems. So let us start today's session. Before that, let us find why the current remains constant in serial combination and potential difference changes. We have learned that electric charges will flow in a circuit only due to applied potential difference. When potential difference is applied, then the electric charges or so-called electrons will move from the negative terminal, and the equal amount of electrons will reach back to the other end, that is positive terminal. So here the amount of charges that start move from the one terminal will end up in the other terminal, right? Now in this case, what happens in serial combination, you see the amount of charges flow from the negative terminal, ultimately it must reach to the positive terminal, and here you see only one path is available. So the amount of charge flowing in a circuit remains same throughout the circuit, right? So since it has only one path, suppose if we have one long pipe, if we pour water from one end, there is no other way for the water to flow, right? It has only one path. When there exists only one path, all the charges will move in a single path. If it is so, wherever you keep the ammeter, the value of I, that is current, remains constant. That is why current remains constant in serial combination. Let us now understand why potential difference changes across each resistor. Dear students, you should know that the resistance acts as a speed bump or speed breaker. Whenever electric current flows through the resistance, then it restricts the speed of flow of the electrons. When electric charges reach the resistance, there the flow of electric charge or the speed at which the electric charges flow gets slowed down. In order to make steady current, work is done on that particular resistance by the applied potential difference. So there we can see a drop in potential difference, right? Similarly, when current flows through each resistor, work is being done in order to make the flow of electric current continuous. So we can see the potential difference changes across each resistor. Got it, children? If you connect voltmeter across each resistor, then you will find different potential difference. Voltmeter reading shows different value. But if you find the total potential difference, then it will be the sum of all the potential differences across each resistor. So this is how the current flowing in a serial combination of resistors remain constant, whereas the potential difference changes across each resistor. In serial combination, we had 3 different positions where the voltmeter could be connected. So we got different values of potential difference, whereas in case of parallel combination, we have only one position, that is A and B. The voltmeter could be connected in only one point. So we get only one value. So we can say that the potential difference remains constant in parallel combination. When we talk about flow of electric current in parallel combination, when the electrons start moving from negative terminal, when it reaches point B, at point B you can see very well that there are 3 different ways where the electric current can flow. So when the electric current flows in 3 different ways, then naturally the amount of flow of charge will decrease, right, or changes we can see. That is why in case of parallel combination, across each resistor we could see different value of current. When you connect ammeter across each resistor, then you will get a different value of current. Let us now understand what is heating effect of electric current. Students, we know that a cell or a battery is a source of potential difference. In a battery or a cell, what happens? Chemical reactions takes place, and there we can see chemical energy. With that energy, the electrons are moving in a circuit. In order to make the continuous flow of electric current in a circuit, then this energy has to be expended continuously. Now, a part of this energy is used to make some useful work. Suppose if in an electric circuit a fan is connected, then the electric charges will move in a circuit by taking the electrical energy, right? When the electrons are moving, then the electrons possess electrical energy obtained from the potential difference, for example cell or a battery. When it reaches fan or any other gadgets attached to the electric circuit, there some portion of the electric energy will be used to carry out some useful work. In case of fan, the blades start rotating, right? However, remaining part of the electrical energy is converted into heat, or we can say it is dissipated as heat and given out, and which increases the temperature of the gadgets attached to the circuit. Now in the case of fan, here after stopping the fan, if you touch the fan, you can feel the warmness, right? So this is how some part of the electrical energy is used up and remaining part is wasted as heat, which ultimately raises the temperature of the gadget. If we switch on the circuit for longer time, then you will find that the gadget get more and more heat. So from this we can say that more heat is dissipated. For example, if the circuit is made completely resistive, then in that case what happens? All the electrical energy is converted into heat. This is what we call it as heating effect of electric current. On the basis of this heating effect of electric current, we use various devices in our day-to-day life. For example, can you name some? Exactly, electric iron, which we use in our everyday life, right? So electric iron is an example of the heating effect of the electric current. Second one is electric cooker is there, water heater is there, geysers are there. So all these are the examples which work on the basis of heating effect of electric current. Let us consider an electric circuit. Here This is the circuit in which the current I flows through the circuit, where it finds a resistor of resistance R and the applied potential difference is V. We just assume it. Suppose the Q amount of charge is flowing in a circuit in time t, then the work done can be found out by W is equal to VQ. In the lower classes you must have studied the rate of doing work is known as power, right? Or the rate at which the energy is consumed is also known as power. By applying the same concept here, we will get power is equal to VI. We know that I is the rate of flow of charge. So I can be replaced with Q by T. So this equation can be modified as P is equal to VQ by T. So we can say that the source must provide energy equal to P into T. Here in the circuit the energy is dissipated as heat, so it is VIT. So here what happens to the energy? We know that when it encounters a circuit, their heat is liberated. If the circuit is completely resistive, then all the electrical energy will be converted into heat. So we can say that heat is equal to VIT. By applying Ohm's law on this equation, we know that V is equal to IR. So applying this, we will get the H, that is heat, is equal to I square RT. This equation is known as Joules law of heating. So according to Joules law of heating, the heat produced in a resistor is directly proportional to square of the current. Secondly, the heat produced is directly proportional to resistance. Third one is the heat produced is directly proportional to time, which means if the resistance of the circuit is increased, then the heat will be increased. If the circuit is operated for more and more time, that is time, if time is increased, then more and more heat will be produced. So this is what Joules law of heating is. Based on this, let us do some numerical problems.
Now look at the question. 400 joule of heat is produced in 4 seconds in a 4 ohm resistor. Find the potential difference. Firstly, we write the given quantities. In the question, heat is given as 400 joule, right? Time is 4 seconds and the resistance is 4 ohm. Now we know that H is equal to I square RT, right? In our equation, nowhere V is given. Here the symbol of potential difference is V, so in our equation we should have V. But we have the idea, right? V is equal to IR. On rearranging, we will get I is equal to V by R. So I is equal to V by R. In our equation we have I square. So here I square is equal to V square by R square. Now substitute in our equation, then we will get H is equal to, in place of I square we write it V square. Here R square can be written as R into R multiplied by R into T. So R gets cancelled, so we will get H is equal to V square by R multiplied by T. So now we have V in our equation. So on rearranging this, we will get V square is equal to HR divided by T, and V is equal to root of H into R divided by T, right? Now you substitute the values. We have all the values, so V will be root of H is 400 multiplied by resistance is 4 ohm and the time is 4 seconds. So here 4 gets cancelled. V is equal to root of 400, and you should know that the square root of 400 is 20. So V is equal to 20 volt. Alright children, let us see another numerical. See the second question. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So firstly we write the given quantities. So here in the question, resistance is given as 20 ohm, current is given as 5 ampere. Calculate the heat developed in 30 seconds. So time is given 30 seconds. So we know that H is equal to I square RT. So here I is given, R is given, T is given. Very straight question, right? Put the values. So I is here 5 square multiplied by R is 20 multiplied by 30 seconds. So here we will get 5, the square of 5 is 25 multiplied by 2 3s are 600 On multiplying this, we will get 150,000, or we can write it as 15 kilojoule. So the heat developed would be 15,000 joule, or we can write 15 kilojoule. Got it, children?
Let us now learn some of the important applications of heating effect of electric current. Students, we know that when electric current flows in a circuit with electrical energy, some portion of the electrical energy is consumed to do some useful work, but some part of the electrical energy is dissipated as heat, and this heat is undesirable since it causes damage to the electrical gadgets, right? Now, some of the applications of the heating effect also there, which we will be discussing. So, as far as class 10th is concerned, we will look into two important applications. First one is on the basis of heating effects, what are all the various devices we are using in our day-to-day life. For example, electrical kettle is there, water heater is there, electric iron is there. All these are the devices which we find very useful in our day-to-day life, right? So, although we find undesirable in some circumstances, but in many other situations we use this heating effect of electric current for carrying out our various day-to-day activities, right? So, this is one way how the heating effect of electric current is very much useful to us. The second application of heating effect of electric current is bulb, which we use in our day-to-day life. Here what happens, the filament of the bulb is totally resistive. We know that when the circuit is totally resistive, then it produces large amount of heat, right? So, when the potential difference is 220 volt, then it can produce large amount of heat. Some portion of the heat is converted into light, which makes the light glow. Here the filament is made of metals with a high melting point. The metals chosen should have high melting point. Tungsten is taken as the filament of the bulb, which have the melting point around 3380, such a large melting point it has. So, it can withstand with a high temperature also. So, this way we can make use of heating effect of electric current for making bulb. The third and most common application of heating effect of electric current is used in fuse. You know the use of fuse, right? In our home circuit also we have fuse. The main use of the fuse is it controls the right amount of electric current to pass through the circuit. If excess current is flowing in a circuit, then the fuse breaks, thereby restricting the flow of charge in a circuit, or the flow of current is totally stopped. The fuse which we use in our domestic purpose is power rated as 1 ampere, 2 ampere, 3 ampere, 5, 10 like that. Depending upon the rating of the power we require, accordingly our fuse should be installed. For an instance, let us take an example of electric current. Let us suppose it consumes 1 kilowatt of power. Then which power rated fuse we need to use? To know this, we should know the amount of current that needs to be flowed in an electric circuit. So, for finding this, we know that I is equal to power divided by potential difference. So, by substituting the values, we are getting here 4.54 some values we are getting, right? So, at this case, we need to use the fuse rated at 5 ampere. So, in order to choose the correct fuse, we should have the knowledge of the amount of current required for the appliance. If we know that, then fuse could be chosen correctly. So, how could we choose? The fuse taken should be slightly greater than the current required by the appliance. If we choose a higher rated fuse than the required one, then at that point, even if more current is flowing in the circuit, the fuse will not break. If we choose fuse with lower rated than the required one, then at that point what happens, even if a smaller current required for the appliance is passed in an electric circuit, then immediately the circuit will break. So, choosing right fuse for the appliance attached with the circuit is very important. Hope you understood this. Now, let us understand electric power. We know that the rate of doing work is known as electric power. So, we can write here as P is equal to VI. We know that the value of V is IR. So, by substituting this, we will get power is equal to I square R. And we know that I is equal to V by R. So, by substituting this, we will get V square by hour. The SI unit of power is watt, and you are very much familiar with watt and all, right? When you purchase bulb, then you see the power rated watt, 60 watt bulb, 100 watt bulb, 40, 10, like that. So more the power, more brightness the bulb will be. So this is how we can understand the power.
So 1 watt is the power consumed by the appliance or a device which carries current of 1 ampere operated at a potential difference of 1 volt. So we can say that 1 watt of power is equal to the product of potential difference, 1 volt of potential difference, and that carries 1 ampere of current. Got it, children? Here the SI unit of power is watt, right? Now this watt is a very smaller unit. In actual practice we use some bigger units of power, that is kilowatt. Kilowatt, and you should know 1 kilowatt is equal to 1000 watt, and the electrical energy is the product of power and time. So the unit of electrical energy will be power. The unit of power is watt, and the time we express in hour, which indicates that the electrical energy consumed if a device consumes 1 watt of power and is operated for 1 hour, then we call it as 1 watt hour. Now in commercial unit of electrical energy is expressed in kilowatt hour. So 1 kilowatt hour is equal to, when a device consumes 1000 watt of power and is operated for 1 hour, then we call it as 1 kilowatt hour. Got it, children? Now this 1 kilowatt hour is said to be 1 unit. So 1 kilowatt hour is equal to 1000 watt hour, which is equal to, we know that 1 hour is equal to 3600 seconds, right? So watt into 3600 seconds. So finally we will get 3.6 into 10 to the power 6 watt second. This watt second is the unit of energy which is expressed in joules. So we can write it as 3.6 into 10 to the power 6 joule of electrical energy. So when we talk about 1 kilowatt hour, then 1 kilowatt hour will be equal to 3.6 into 10 to the power 6 joule of electrical energy, and this we call it as 1 unit in a commercial purpose. On the basis of this, let us do some numerical problems. Now look at the question. A household uses the following electrical appliances. What are those? A refrigerator of rating 400 watt for 2 hours for 30 days. The second appliance, 2 electric fans. Here you see 2 electric fans of rating 80 watt each for 12 hours each day. And the third one is 6 electric tubes of rating 18 watt each for 6 hours each day. So here calculate the electricity bill of the household for the month of June if the cost per unit of electric energy is ₹4. To solve this, firstly we have to find the total unit consumed. So power rating is given, we have to find the power consumed by each appliance for 1 day multiplied into 30 days. So we will get the total power consumed by each appliance for a month. If we know the total power, then from that we can find the total units, and from that unit by multiplying it with 4 we will get the cost. Here we will do step by step. Firstly we will find energy consumed by refrigerator of rating 400 watt for 2 hours each day. So the energy consumption will be power into T. So we know that power rating is 400 watt multiplied by time is 2 hours. So 30 we have to multiply. First we find for each day, then we can find for 30 days together, right? So here we will get 2 4s are 8. So here 800 watt, right? Now this has to be converted into kilowatt, because we have to find the units. 1 unit, we have learned that 1 unit is equal to 1 kilowatt hour, right? So we have to convert this. Time is in hour, so here watt has to be converted into kilowatt. Here 800 divided by 1000 kilowatt hour, right? So 0 gets cancelled, so finally we will get 0.8 kilowatt hour. So this is the energy consumption of the refrigerator for one day. We have to find for 30 days, that we will do later. Second, we have to write the energy consumed by two electric fans of rating 80 watt for 12 hours per day. So that we will write. So again the same formula we will use, P into T. So here you see two electric fans, so we write 2 into each electric fan rated 80 watt. So here we can write 80 divided by 1000 kilowatt, right? For 12 hours we write here 12 hours. So upon solving this, what we get here get cancelled, so here we will get 2 12s are 24 into 0.08 kilowatt hour. So upon solving this, we will get 1.92 kilowatt hour. Third, we will find the energy consumption by 6 electric tubes of rating 18 watt for 6 hours. Here also we will use the same formula, that is P into T. Here to find the power we have 6 electric tubes. So we will write 6 and each electric tube is rated 18 watt. So we will write 18 divided by 1000 kilowatt, right? Multiplied by 6 hours per day. So that we will write. So here we will get 648 divided by 1000. Finally we will get 0.648 kilowatt hour. So here we have got individually the energy consumed per day. We have to convert it into 30 days. So we will write that will be equal to, here the energy consumed by the refrigerator, that is 0.8, plus the energy consumed by two electric fans, that is 1.92, plus the energy consumed by 6 electric tubes, 0.648, right? So this is for one day. For converting it for 30 days, we have to multiply it by 30. So by solving this, we will get 3.368 multiplied by 30. Upon solving this, we will get 101.04. So this is the total energy consumption for 30 days. Now we have to find the total amount, and this is kilowatt hour. We know that 1 kilowatt hour is equal to 1 unit. So here in the question it is given that you have to find the cost per unit of electrical energy, that is rupees 4, right? Total units consumed is 101.04 units. So each unit costs 4 rupees. Total cost could be found out multiplying it with 4, right? So the electricity bill of the household for the month of June will be, that will give you rupees 404.16. Got it, children?
Hope you understood the numerical problem. So we have completed the chapter electricity. Hope you understood all the topic clearly. So with this I would like to conclude today's video. Before concluding, I would like to give some easy home assignments which you can practice at home. So here is your home assignment. All these home assignments very easily. See you all on another day with a new chapter. Till then, take good care of yourself.